Alrighty, welcome to video number 3 on data visualizations, and in this video we'll be talking about bar plots in Matplotlib and Seaborn. So bar plots essentially show the relationship between a categorical variable and a numerical variable, where our categorical variable is represented on the x-axis and our numerical variable is represented on the y-axis. So essentially, we want to go back to our data set and figure out some of the categorical variables that we thought had a strong relationship to revenue. And actually, in the previous video in line plots, we found a couple of variables which include belong to collection and original language that actually do have a pretty strong correlation. Let me rephrase that. These two variables, we couldn't really demonstrate their correlation through line plots, but through bar plots, because they are categorical variables, we'll be able to get a much better visualization and understanding of how these correlate to total revenue. Okay, so let's start with the code that Matplotlib has for bar plots. So essentially the code for this is going to be plt.bar. And plt.bar this time will take in it'll take in two different arguments. But this time, instead of an x argument and a y argument, we're going to have an x argument and a height argument. Height argument is essentially the same as our y argument, but in Matplotlib, it's just represented as the height. So if we wanted to draw our graph for this, so we'd do x is equal to table name, and then we would index into our columns, and then our second argument will be height, and this same thing will index into our column. So that's how the code is essentially going to look for a bar plot. And obviously we're going to want to have an X label, a Y label, all that stuff. It's the same code across line plots, bar plots, etc. But the difference here is that we have to realize that when we're finding relationships between categorical variables in our graph, not every categorical variable has the same amount of they're not all the same. Like, because we have 3,000 rows in our table, like, we're not going to have the same amount of yeses and nos for belongs to collection. There may be 2,000 movies that don't belong to a collection and 1,000 movies that do belong to a collection, if that makes sense. Or for original languages, we might have a lot more movies that were spoken in English than movies, for example, that were spoken in Hindi. So instead, what we're going to want to do is, for our height column, we're going to want to take the basically the average of what's displayed on the X. So for example, if we had like the categorical variable belongs to collection on the X with a yes and a no column, and on our y-axis we had revenue, we're going to want to take the average revenue for the movies that did belong to a collection and movies that did not. Notice how it said average instead of total, just because, like I mentioned, there's not going to be the same number of yeses and nos, or English and Hindi or Chinese or whatnot. So we need to be really conscious of that when drawing our bar plots. And in Matplotlib, actually, so in Seaborn, the default argument is average. The default y-axis is the average of the x-axis, if that makes sense. Like, if we decided to make our visualization in Seaborn for belongs to collection on our X and revenue on our Y, it'll automatically compute the average revenue for movies that belong to a collection and that do not. But if we do it in Matplotlib, the default Y measure is not the average of yeses and nos. So we're going to have to specify that in Matplotlib, and we're going to have to create a new graph to pass into Matplotlib, which does have the averages of the yes and no values in our categorical variable belongs to collection. So let me just write down here. Basically, we're going to want to create a new table. And our new table, we're going to have our old table, and we're going to group by the um, variable that we're trying to find on our x-axis. So before we look at these two variables that I talked about here, before I inspect those more closely, I want to talk about a completely different variable first, and that is the variable year. Because I mentioned to you guys that year can be considered either a categorical or a numerical column, the value. So why don't we assume here that year is categorical, okay? So say we wanted to group by our release year, because again, there's not going to be the same amount of movies produced in year after year. So we're going to want to find the average revenue for the movies produced in that specific year. So say we group by release year, and we take the mean of those revenues. Okay, so let's see. Oh, sorry, group by. Okay, cool. So essentially what we have right now is a table that has grouped all the numerical counts, has taken the mean of all the numerical counts in our graph. But all we want really is just this column right here of revenue. So all these other columns are not essential to us. But what we're going to be doing is we're going to be graphing making a bar plot out of this data. So I want to introduce a really cool argument function called plt.figure. So plt.figure, actually we can manipulate how large we want our graph to be, if that makes sense. Back over here we had a really small line plot, but in the case of bar plots, because we have like bars on our x-axis, we're going to want our bar plots to be a lot more extended out, a lot longer and a lot larger than the graphs that we use for line plots. So over here we can pass in an argument called fig size, and fig size takes in two values, the length and the height. So 15 and 8 is a really large graph that I chose would be perfect for this problem. So then we would just continue with our visualization, and in this case we would call x our new table dot index, and I'll explain why I do that. And the reason is because when we have our new table, I can demonstrate it right here. When we group by release year essentially becomes the index for our graph. So we're going to want to, because we want the release year to be on the x-axis, we can't just index into the release year column because that column doesn't exist in our table, but it exists as an index. So we would have to call it as new table.index to get our release year. And our height would be revenue in this case. So when we do that, we get our graph right here. And actually, let me just, because this is matplotlib, they don't automatically get our x and y axes for us. So let me just copy those down here. So release year is on the x, and then revenue is on the right. And then our graph essentially demonstrates the average revenue for all these release years. And we can tell that there is a pretty positive correlation. I mean, it's generally increasing over time, with a few dips, and that could be external factors that we have no control over. But generally, there is the positive relationship in that movies had a higher average revenue as time went on. And we can actually test this relationship by using a line plot, because remember how I mentioned that release year can be considered both a categorical and a numerical variable? So that would be really useful. That information would be really useful here in the sense that we can draw a line plot because we have a continuous numerical variable which can also be represented as a categorical variable. So say we chose to draw a line plot in Seaborn using the same exact, let me actually, sorry, call it the original table. It's the same exact values. And in this case, x would be our release year, and y would be our um, revenue. So the thing is with this, when we draw this graph, revised movies is the table. Sorry. So when we have this visualization, this pretty much confirms our hypothesis that we thought about here, that movie revenue generally increases with time. So yeah, you can see the distribution a lot more clearly here. There's a little bump in 1975-ish that you can also observe in our graph, our categorical bar plot right here, a little bump that goes back down and then generally increases. So that's a really cool feature about Seaborn, that the graphs are pretty much the exact same across the bar plot and the line plot, confirming our hypotheses that release year is a pretty good estimator to an increase in revenue. We're gonna keep that in mind. Yeah. Okay. So let's go back to our first question in line plots, because we were having a little bit trouble figuring out whether these two variables, belongs to collection and original language, really had a correlation with revenue, because it was very hard to tell with the line plot. But we can reproduce these graphs using a bar plot because these two are categorical variables. So let's start off talking about the categorical variable belongs to collection, whether a movie belonged to a larger series of movies or not. Okay, so using the same exact functionality, we can just draw a graph. So PLT. So okay, again, because this is matplotlib, every time you have to realize that because our default y values are not actually the average, we have to kind of remake our graph and group by our x variable and aggregate by the mean, essentially, because we have to reproduce the graph and make it such that it would give us an accurate description of the average revenue in matplotlib, which again we won't have to do in Seaborn because that's the default numerical value for Seaborn. So in matplotlib, we're going to just have to call a new table, so we can call that table S. And in this case, we can group by the numerical categorical column belongs to collection, and we can aggregate by the mean. So now our table S is created. And again, if you take a look at our table S, our belongs to collection variable now becomes the index of our table, and then we get the mean of all the numerical values in our table. And again, we're only going to want to talk about this revenue column right here. And already we can tell that there's a pretty big difference between the average revenues for movies that belong to a collection and movies that didn't. But let's just draw a visualization to confirm what we thought. So we can do plt.bar with x as s.index and y, our height variable as s pentarevenue. Okay. Oops. Okay. So our x plt.x label is belongs to collection, and our y-axis is labeled revenue. So let's take a look at what this graph displays for us. Wow. So our initial hypothesis was correct, that there is a huge difference in the revenues generated by movies that belong to a collection and those that didn't. So if we go back to our line plot, we would never think that that difference is as big as what we see in our bar plot, which is again why a bar plot is so much more useful for visualizing categorical variables. So that's a really cool difference that we just noted, and that also shows why line plots probably aren't the best choice when we're measuring categorical variables, despite the Hue argument that this is much more accurate and much more easier to tell how large the difference actually is. But let's inspect this difference a little bit more closely in Seaborn, because there's actually quite a few interesting features to why this difference is so large, so much larger than we originally thought in our line plot. So let's pivot over to Seaborn. So now that you guys know how to draw line plots in Matplotlib, the notation in Seaborn also is very similar to Matplotlib. And in this case, a bar plot is represented as sns.barplot, and we can specify our data as our table name, and we can specify our x value as our column name, And instead of taking the height argument, we're just going to give make it easier and just have a y argument instead of height. Let me just put these in strings. Okay, so this is going to be our code for a Seaborn bar plot. Okay, so now that we know that movies that belong to a collection tended to generate much more revenue than those that didn't, let's use Seaborn to be a little bit more specific and break down this relationship even further down by looking at the differences between the average revenues over each month. And again, month is another categorical variable that we have in this case. But unlike matplotlib and line plots, we can't just add a third argument like y2 or anything, specifying our second, our second or our third categorical variable of movie release month. But because this is Seaborn, we can use the hue argument that we saw over in line plots. The hue argument is standard over all of Seaborn's visualization tools. So we can use that hue argument in this case too. So let's do that. Let's go to sns.barplot, and we can specify our data as revised movies, x as release month, y as revenue, and hue as belongs to collection. That's going to be our our second categorical variable besides for the release month. Because again, release month is considered a categorical variable along with the numerical variable. So when we graph this, also before we graph this, if you guys notice why I didn't change this, put this release month over in the hue section and put belongs to collection here, like our last graph, the reason is because when we graph this, it's going to look a little bit wacky. It's a little hard to understand the differences between, because the graph becomes very, very cluttered, and like we can't see this graph mainly tells us, basically it tells us the differences in revenue between months over this categorical variable belongs to collection, but we're not interested in that. We're interested in the differences between the differences in revenue of movies that belong to a collection versus those that didn't over a single month. And because we're going to want to see it over a single month, we're gonna want to put release month as our x-axis variable and belongs to collection as our y-axis variable, because this will give us a graph that tells us in the first month of January, this was the difference between movies that belonged to a collection and those that didn't. Same with the second month, third month, so on and so forth. So for the point that we want to try to get across, this is the best visualization that we can have. And immediately we can see that there is in fact a huge difference between movies that belong to a series versus those that didn't. In every single month, actually, the difference is pretty big. So again, the minor difference that we saw over in our line plot, this very little difference over here, is showing to be so much more greater in a bar plot, which is really cool. So yeah, but also with this graph, we can see that, hey, why is our average revenue in June and July, actually sorry, May and June, so much higher than it is in January and August, September? And this actually relates back to the line plot that we observed in matplotlib of movie release month versus popularity. The only difference is that in this graph, our y-axis label is popularity index instead of revenue. But if you think about it, popularity and revenue should be pretty correlated, because the more popular a movie was, the more people want to view that movie. So it absolutely makes sense why the two distributions showed in our bar plot over here and our bar plot over here make so much sense, so much intuitive sense to us. But anyways, let's actually investigate why this is the case, and let's take out this belongs to collection variable, this optional categorical variable. And let's just view the difference in distributions every month. And you can see that, hey, there is a pretty large distribution difference between the months of May, June, July, and January, August, and September that was displayed in this graph. So month is actually proving to be a pretty good um, variable that correlates with an increase in revenue, essentially. But something else that I want to point out is these little black bars that you see over here. And essentially, these black bars are pretty much the same thing as the shaded area that we viewed in Seaborn in line plots. Because the shaded area right here shows us the variability of revenue at every single X point. At this specific budget, the variability was pretty big. Same with bar plots. In the month of um, in the month of June and July, the variability was pretty large for movies in terms of revenue. While in January, the variability was pretty small. So that's pretty important to understand that again, if we chose to add a second data point or another data point to our data set that was made in that was released in June, that movie's revenue will likely fall between these two bars with an average of this value right over here. So that's going to be really important to understand moving forward. Okay, so now that we understand that our initial variable belongs to collection that we were kind of uncertain about at first, now that we understand that this categorical variable is actually really key in determining, a movie's revenue, let's move on to our next variable, which is original language. Now, over here in our line plots, we noted that English did tend to have a lot higher of a budget. English movies had a higher budget as well as a higher revenue for those levels of budget. So let's take a look in bar plots in our Seaborn bar plot to see whether this difference is actually as large as we saw in our line plot. So again, we're going to be using the POT.figure fig size argument just because we want to exemplify this on a much larger scale because there's so many different languages in our original language column. So let's make our fig size 15 and 8, and then we can call sns.barplot movies x as, and again, because original language is our categorical variable, we're going to want to put that on the x-axis, and y being our numerical variable is going to go on the x-axis. So if we graph that, we can see that we have a pretty good visualization of this. But there is something that's very much different than we observed in our line plots. Actually, movies that were produced in English don't have that much of a higher average revenue than movies that were produced in ZH, which is Chinese, um, or even TR for that matter, which is known as Turkish. So that's actually really interesting. Um, and we want to figure out why is this the case? Why is our line plot so misleading then actually? And the reason is because if we go back to our line plot, we're only assuming that for those levels of higher budget, that English movies had a much higher revenue. But the fact of the matter is, some of the other movies produced in different languages didn't have nearly as high of a budget as English movies did. So we couldn't really view the amount of revenue they pulled in for those extremely high budgets. We can only really compare all the movies from this value of $0 to zero point 0.5 times 10 to the 8th. This is really meaningful to us because all the data points lie in this, most of the languages lie in this little box right here. So essentially what our bar plot is exemplifying is that our bar plot really is ignoring all this misleading information after, zero point 0.5 times 10 to the 8th dollars, and it's only focusing in on this little box that we have over here, which is showing that English movies are really not that much more profitable essentially compared to Chinese movies or some of the other movies, even though they do still have a pretty big grip over some of the other languages, but it's not nearly as big as we thought it was. But it's very interesting though because some of the variability for English movies is really small. And if you guys remember from our statistical modeling lecture videos a few weeks back, variability is really determined on the number of sample sizes we have. So English has a really small variability because a lot of the movies in our data set have an original language of English, whereas Chinese or Turkish have a really, really high variability because not that many movies in our data set were produced in Chinese or Turkish. Maybe one movie in our data set was observed to be produced in Turkish, and by coincidence, that movie had a pretty high revenue. That's why if we select a second movie out of random and we add it to our data set, that movie can either have a revenue of zero or it can have a revenue really high. We really don't know because we only have one sample Turkish movie to compare that other data point to. And that's really the intuition behind these black bars that we observe over here. Okay, so that was really cool. We were able to prove and disprove some hypotheses that we had about these categorical variables in line plots. So now that we've finished covering bar plots in Matplotlib and Seaborn, let's see. Let's just recap really quickly and add on to our list which variables that we saw actually do have a pretty big correlation to revenue. And going back to our previous list, we can confirm that budget does in fact have a pretty big relationship, and so does belongs to collection, as we noted by this huge difference in our graph. But original language really doesn't have that much of a correlation to revenue because movies that were produced in English really didn't have that much more of a revenue than movies produced in other languages. So we can safely assume that the first two of these are really critical in determining movie revenue. So let's just repeat those: budget and our second one was belongs to collection. But we also saw in this section that our release year did have a pretty positive correlation and that movies in recent years tended to have a higher revenue. And movies in June, July, and May also did have a higher revenue than movies that were produced in January or August or September. So we can add these two to our list as well: release year and release month. So all in all, so far, we've found these four variables to really be strongly correlated with our total revenue for all the movies. So thanks for tuning into this video, and we'll be talking about scatter plots in our next video.